Hi everybody. Today we're going to be talking about factoring trinomials when a is equal to 1. So this is called a trinomial, ax squared plus bx plus c, and we're going to go backwards. So like this would be the answer after I distributed or did the box to find the, add all the stuff on the inside and figure out my final answer. So let's just start just a step before that, and let's do, for instance, w plus 6 times w plus 2. So what we're going to do is, remember, we would draw the box, and we would put w plus 6 on one side, and we would put w plus 2 on the other side, and split them up into their terms, and then we would multiply into the box. So we had w times w was w squared, w times 6 was 6w, 2 times w was 2w, and then 2 times 6 was 12. And then remember, after that, we would take these two ones on the diagonal, we would add them together because they were like terms. So 2w plus 6w made 8w, and then we would write our final answer, which is w squared plus 8w plus 12. So we got w squared came from this box, 8w came from in the corner here when I added the two middle terms, and then the 12 came from this bottom corner. This is in the form of ax squared plus bx plus c, which is what we were talking about at the top here of factoring trinomials. So we can kind of work backwards to figure out our answer. So ax squared, that very first term up here, came from this corner box right here. So this corner box is going to be our ax squared. And then that middle term, bx, well, that came from adding these two diagonal boxes together, right? That's how we got bx. And then the last term, c, that one came from this corner here, or, this corner of the box down here. And so they multiply to that. So what we are going to do today is strictly decide when a is 1. So instead of having like 2x squared or something like that, we just have a 1 in front of all of them. So it's a little bit easier than when the number is 2 or 3 or 4. So we're going to focus on that today, okay? So there's a couple of things that we need to look into when we're doing this. And the first one is we will need to make a factor table for a times c. In this problem, a is always going to be 1, so really we're just making a factor table for c. But we have, if ac is positive, then that means that we would be adding these two here. And if ac is negative, then that would mean that we were subtracting the two blue ones, okay? So we're just talking about if c is positive, then we're going to add the blue. And if c is negative, then we're going to subtract, whoops, that should say subtract the blue. All right, and so we're going to talk about this. All of this here is going to make a big difference in just a minute, and we'll talk about why. So let's just go backwards and then work on this problem right here, and it should make sense, okay? So we're going to start by saying, x squared was the first one. We put it in the first box. And then we've got 20, where did my pink go? I put it back. 20, that last term there went in this box over here. And then that 12x that's in the middle, well, we got the 12x from adding these two middle terms together right here, okay? So that box is going to add to 12x, and this bottom box is going to multiply to 20, and it's positive 20. So then we're going to look at that factor table, which is what you were doing in the previous video, of 1 times 20, 2 times 10, 4 times 5, and we know we're finished because the next one would be 5 times 4, which would be the same thing. And we're going to look at two numbers in this table that add to 12x and multiply to 20, okay? So all of these multiply to 20, so now we're just going to figure out what they add to. So 1 plus 20 is 21, 2 plus 10 is 12, and 4 plus 5 is 9. So the two factors that add to 20, or sorry, add to the 12 and also multiply to 20 are 2 and 10. So what we're going to do is we're going to take 2 and we're going to put it in this blue box. But remember, in our blue box, that was the one that had the one variable, right? Because when they add together, they have to be 8w. So here we need to say this is 2x, and up here we're going to say that it is 10x. So 2x plus 10x make 12x, okay? So we're going to put those split into the middle box. And then all we're going to do is find the GCF of each row, okay? So just like what you were doing before. So what is the greatest common factor between x and 10x? Well, it's really 1x squared and 10x, right? And the biggest number that goes into both 1 and 10 is just 1. So we know that this is 1. And then I need to get x squared. They both have x, right? So we can say this is 1x, okay? And remember from this box here, to get my w squared, I needed to do w times w. That's kind of like what we're doing right here, okay? So to get x squared, I need to do x times x, okay? And then to get 10x, well, I need to do x times what to get 10x? Well, I know that's positive 10, okay? Now we're going to do the same thing with the bottom row. So we're going to say we know x plus 10 is the top, so now we just need to figure out what goes right here so that it multiplies to make 2x, and these two multiply to make 20. And that's easy. We know that's going to be 2, and it's a positive 2. Okay? So now this was the answer to our multiplication problem, and we figured it out by doing the GCF of each row. And so now we're going to write the factors, okay? The factors are the outsides of the box. So the outsides of the box, so the factors are, we've got one side which is x plus 10, and the other side which is x plus 2. And this is called factored form, or these are the factors of this problem, okay? And this up here is kind of a summary of all the things we're going to talk about on the inside examples, okay? So let's go inside and let's work on some of them. So we'll do w squared plus 8w plus 12. So remember we did green, blue, and pink. So green will be the first one. And we're not always going to color code, but for right now we're going to for this just this next problem. Green, blue, and pink, okay? And we can only do this factored and solved thing when we have it equal to 0, so that's why this problem ends with equals to 0 at the end there, okay? All right, so we're going to start off, we're going to draw the box. And we're going to put 4 pieces because we have a trinomial, and then we're just going to put the pieces where they go. So remember, w squared goes in the first box, 12 goes in the last box, and then 8w is made by combining these two boxes together. So I'm going to put 8w on the outside. Now, the next step is to figure out what two numbers multiply to make 12, because those are the numbers we're going to put here and here. And we have positive 12, so that's easy. We're just going to write positive 12, and we're going to figure out those numbers. So we've got 1 times 12, 2 times 6, and 3 times 4. Okay? Remember, after that, we need to multiply to 12w squared and add to 8w, right? So this one's the add, and this one's the multiply. So now we need to figure out what these add to. So this one adds to 13. These are notes, so we're just going to write the addition on the side, but we're not always going to write this. 2 plus 6 is 8, and then 3 plus 4 is 7. So the ones that multiply to 12 are all of these. The one that adds to 8 is going to be this middle one, 2 and 6. So remember, we're going to put 2w here, and we're going to put 6w here. And really, you could have switched them, and that would have been okay, all right? As long as you split them up, and one of them goes here, and one of them goes here, it doesn't matter which one. Because remember, now we're going to do the GCF. So remember, to start off on the top, this one's easy. W squared, we get that by doing w times w. And then to get 6w, well, we have to multiply this w right here by 6. And it's a positive 6. Okay? Now to get this last piece right here, well, in order to get something times w to be 2w, we know that's going to be a positive 2. And then we're just going to double check, does 2 times 6 make 12? Yep, we did it. So now we'll write the factored form, which is w plus 2 times w plus 6, and that's equal to 0. This is called factored form. This is important. We need to know the difference between factored. And then you might have remembered from the last class that we did some solving where we drew the arrows below and we said w plus 2 equals 0 and w plus 6 equals 0. Subtract 2 on both sides. W equals negative 2. Subtract 6 on both sides. W equals negative 6. Those cancel. This line right here is called solved. Okay? So we have two different things, and we need to be very aware of that, okay? Because they're going to ask you to just factor, and that means you're literally just going to do the parentheses, okay? But if it asks you to solve, then you need to come all the way down to the W equals part at the end, okay? All right. Let's work on example 2. So example 2, same thing, but now instead of having all pluses, we start throwing in a negative in here, okay? So we're going to draw our box just like we did last time. 3 terms, so it gets the 4 pieces. We put k squared here. We put positive 42 here. And then together, these two need to make negative 13k. And they're going to add to negative 13k, remember? All right, so now we're going to make our factor table for 42, so go ahead and take care of that. It's 1 and 42, 2 and 21, 3 and 14, 6 and 7. And I know I'm done because the next number would be 7, and that's already in my table. The next step is to figure out which ones of these add, since this is positive 42, which ones of these add to be 13. So 1 plus 42 doesn't add to 13, it adds to 43. 2 plus 21 adds to 22. We got 3 plus 14 adds to 17, and then 6 plus 7 adds to 13. So this is going to be the one we want to pick, okay? Remember, we can put them in either box, it doesn't matter. So I'll put 6k there and 7k there. And now we go find some GCFs, right? To get k squared, that's the only way, is k times k, so we're golden here. And then to get 7k, we have to multiply by 7. Here's the problem. 6k plus 7k is positive 13k. If I want negative 13k, then I have to make both of these negative, because a negative 6 plus a negative 7 gets me a negative 13. Okay, so if my 7 is negative in my table, then I have to put a minus sign in my factor, right? Because k times negative 7 is negative 7k. And then the bottom, we have the same thing. We've got our negative 6, so we know we have to say minus 6 on the bottom factor. Okay, so if our last term is positive, we're going to add in our table to make that 42. But if the middle term is negative, then that means that they're both negative in my table, okay? That's the only way I can get it to be negative 13k, okay? So now we'll write our factored form. K minus 7 times k minus 6 equals 0, and that is what we call factored. And now we will solve. And solving today is super simple because they're all one-step equations, right? So this one we know k equals 7, and this one we know k equals 6. And honestly, this one, since it's a one-step, I don't mind if you just write this line and then write your final answer underneath it. Sorry, write this line and then write your final answer underneath it. I'm totally cool with that. Okay? So remember, this is factored form, and this means to solve. Okay? All right. Let's take a look at another example. In example 3, we have the same situation. We've got a negative here and a positive here. So remember, we're going to make our factor table for 6 like we've been doing. Let's fill out our box first. X squared 6. This is negative 5x. But we're going to make our factor table for positive 6. So we'll say 1 and 6, 2, and 3. There are no more that make 6, right? So then we're going to say, hey, it's -5, but I have to add. So this makes 7. This one makes 5. So we're going to go with 2 and 3, 2x and 3x, but they need to be -5x. So we're going to say -2 and -3. Then we just go and make the outsides of our box. So we've got x and x. Oh, I want to use red, sorry. X and x. And then to get -3x, we got to go -3. Okay? And then to get -2x, we got to go -2 because -2 times x is -2x. And -2 times -3 gets us our +6 that we were looking for. All right, so now we're just going to write our factors, x minus 2 and x minus 3. Remember, the factors come from the sides of the box, okay? This is called what? Factored form. And now we're going to solve. So solving, remember, is just writing down the two equations, or 2 parentheses equals 0. Those are the factors. And remember, I said since it's a one-step equation, I'm totally cool with you not showing that one step because it's kind of easy to do in your head. And this is called solve. So solve is when you get the x equals, and factor is when you get the parentheses. All right. So this last equation is a little bit different because all the equations before have said equals to 0, right? All of them say equals 0. This equation does not say equals to 0. So before we can do anything, we need to set it equal to 0. So what has to move so it says equal to 0? We have to move the 18. So we'll go minus 18 on both sides. Pen's running out. Boo. Okay, minus 18 on both sides. So those cancel, and I end up getting 0. Remember that we cannot combine 18 with -7x, and it also cannot go with with positive x squared. So we'll go x squared minus 7x minus 18 equals 0. Now we'll draw the box. Ooh, this one's different. This one has minus 7x and minus 18. So we've got two minuses in here. How does that change things? Okay. So let's go ahead and fill in what we know. We have x squared and we have -18, but we ended up with two minuses as our answer, okay? So I'm going to go back and find an example to show you real quick of something that shows our answer as two negatives. And let's look and see what happened when we had that example, okay? Okay, so we have this example right here where we have x plus 2 and x minus 4, and we ended up getting -2x and minus 8 in our problem. The reason that we get a minus 8 comes from the two pieces here of my box, right? This one's negative and this one is positive. So they're opposite signs. And so when I come in here and multiply to get these two pieces, I end up having a -4x and a positive 2x. So really I end up subtracting to get 2 in this problem, okay? So if I have a negative down here in the far right corner, then that means we are going to subtract when we get to our B term, okay? So let's take a look at this problem. We're going to make sure that instead of adding here, we are going to subtract to get -7x because of this minus sign in front of the 18. Okay, so we're going to make -18 as our table. We got 1 and 18, 2 and 9, 3 and 6. This isn't the first time we've done this table today. All right, and then anything else in that table? No, because we get up to 6 and it's going to repeat again, right? So now, instead of doing 1 plus 18, because that's not going to happen, remember one of my factors has to be negative and one of my factors has to be positive in order to end up negative at the end. So that means we would be subtracting these, okay? So 1 minus 18 is 17, and then 9 minus 2 is 7, and 6 minus 3 is 3, okay? So this one subtracts to 7. If I want it to end up being -7, then I need to make sure that my 9 is the one that's negative so that I can get negative 7. So I'm going to say positive 2x, and I'm going to say negative 9x. And then 2x minus 9x gets us that 7x that we were looking for. Okay? Now we just go through and do that GCF thing we've been doing. So the thing that they have in common for the x squared is just x and x. And then to get negative 9x, I'm going to put minus 9. And then down here to get 2x, I'm going to put plus 2. Okay? So now I've got my factored form. What are my factors again? The outsides of the box. So I've got x plus 2, and I've got x minus 9 equals 0. That's factored. Now we solve. X plus 2 equals 0, x minus 9 equals 0, x is the negative 2, and x is the positive 9. And this is called solved. Okay? So factored is the top with the parentheses, and then solved is when I can get out there and figure out what x equals. So if we go back to the front of this page and just kind of look at our factor tables, well, before we do that, the only problem on this inside page where we needed to subtract was the one that had a negative in this bottom corner box, okay? Everything else had a positive. So if we have a positive on top of our factor table, we're going to add. And if we have a negative on top of our factor table, we're going to subtract. So that's what they were talking about here, okay? In here where it says if it's positive, you're going to add, and if it's negative, you're going to subtract. Okay, so when you look at these, you'll add them or you'll subtract them based on the sign up here. Okay? And then you have to decide, okay, if it's positive and the middle term is negative, then remember these are both negatives. Okay? But if we have a subtraction sign at the top of our table, only one of them is going to be positive and one of them is going to be negative. All right. Thanks so much for watching. Have a good day.